Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello everyone, it's my pleasure to welcome all senior 6 students in this math lesson. Of course, my name is John, you still remember my name. We are in unit number 4 of integration, of course, where we are dealing with integral of trigonometric function. We met different cases of integral involving trigonometric functions. And you remember last time we had a power function in sine and cosine. The case we had last time was when the index or the exponent is even number. I told you that the linearization can work for both when n is even or odd. Even reduction formula, even didn't use that method, it can also work. So let us have another case of power function in sine cosine with exponents odd number. But before that, we have one simple exercise where we have to evaluate this integral using the linearization. You are going to use linearization. I give you few seconds to evaluate that integral using the linearization. Means that you have to think about the Euler formula for cosine, of course, or in sine. So please hurry up. Remember that cosine of x is e power ix plus e power negative ix divided by 2. And for sine x is e power ix minus e power negative ix divided by 2i. So as you have sine, so it's clear, you see which formula is going to be applied on that activity. Are you done? Very nice, okay. Thank you very much. So I'm going to use this second formula as we have the trigonometric function in sine. So we know that sine cubed of x is equal to sine x power 3, means that you replace sine by e power ix minus e power minus ix divided by 2i power 3. I'll be having 1 divided by 2i power 3, then e power ix minus e power minus ix, result power 3. So this will be 1 divided by 2 power 3 is 8, I power 3 is I cubed. And here we have 1 e power 3 ix minus, pay attention, 3 e power 2 ix minus ix plus 3 e power ix minus 2 ix, then minus e power negative 3 ix. Remember that I squared is equal to negative 1. The complex numbers. So I power 3 is equal to I squared times I. As I squared is minus 1, I have minus 1 times I, which is equal to negative I. So here I have minus 1 divided by 8i times e power 3i x minus e power negative 3i x, then plus 3 power e power I x minus e power negative I x, like that, is ix minus 2ix is minus ix, and 2ix minus ix is ix. So this can be written like minus 1 divided by 4 times each term will be divided by 2i. And I have e power 3i x minus e power negative 3i x divided by 2i, then plus 3 e power I x minus e power negative I x divided by 2i. And this is negative a quarter. You see this form, minus and 2i, so, and the n is 3, that is sine 3x plus 3 sine x. This is very clear. Therefore, the integral of sine cubed x dx is equal to 1 divided by 4 integral of sine of 3x plus 3 times sine x dx. So this is equal to 1 divided by 4 integral of sine 3x dx plus 3 divided by 4 integral of sine x dx. And as we have a sine ax, a is equal to 3, the integral will be minus cosine. So this will be minus 1 divided by 12 cosine of 3x minus, remember here we have a negative sign. I made a mistake. There is a negative sign there. And this will be negative, and at this level it will be positive, yes. Will it be positive? Let me see. All right. So this will be 3 divided by 4 cosine x plus c. Check if your answer is correct, if there is a mistake or not. Is there any mistake? So it means from here, yeah. When you take negative, sorry, there is a mistake at this level. This should be minus, this should be minus. All right, negative. And here also is negative, means that this is negative sign, all right? And when you multiply, here it will be negative. So this is minus and positive. And then this will be positive, it will be minus cosine 3x divided by 3. And here it will be minus. Okay, so when you work with sign, you have to be very careful. So it is easy to make a mistake. But at this level, as we are mature enough, so this is not a serious case. Okay, let us continue with our lesson. Still is integral of this form, integral of cosine nx dx, then integral of sine nx dx. And for this case, we're going to take n to be odd number. Not even. How to evaluate those kind of integrals? where n is odd number. Odd number, understand that 1, 3, 5, 7, and so on. Okay? Let us explain a few examples. Integral of cosine cubed x dx. How to solve, how to evaluate those kind of integral? We can use this trigonometric identity, cosine squared x plus sine squared x equals 1 for any value of x. X is a real number, of course. So, this integral can be written like this: cosine squared x times cosine x dx. So using this trigonometric identity, I can express cosine squared x in terms of sine squared x. So it means that from here, cosine squared x is equal to 1 minus sine squared of x. Do you see? Means that my integral becomes integral of 1 minus sine squared x times cosine x dx. And when I expand this, I'll be having 1 cosine x dx minus integral of sine squared x times cosine x dx. Do you see? And we know that the integral of cosine x is known already. It is a standard integral. It is it is sine x. Then minus integral of sine squared x times cosine x dx. Here I'm going to use the method of integration by change of variable. So we let sine x equals z, for instance. Differentiating both sides, of course, with respect to x and z, I'll be having cosine x dx, which is equal to dz. Is it difficult? I hope not. It's very, very clear. And when I observe my integral, already cosine x dx is here, and is dz. And the sine x is equal to z. I'll be having sine of x minus integral of sine x, that is z, squared. Cosine x dx is dz. And I get sine x minus 1/3 z power 3 plus c. Replacing z by its value, the answer will be sine x minus 1/3 cosine, is it cosine or no? Sine cubed x, then plus c. And I'm done. Do you see how this trigonometric identity is very, very important? Is that clear? Very nice. Maybe you need another example. Let us have another example. I take integral of sine cubed x dx. This was number 1. Using the same method, I'll be having integral of sine squared x times sine x dx. And I express sine squared x in terms of cosine squared of x. Means that I have integral of 1 minus cosine squared x times sine x dx. expanding this, I have integral of 1 sine x dx minus integral of cosine squared x times sine x dx. Hope you are following. Are we together? Okay, very good. So the integral of sine x dx is known to be negative cosine x, then minus integral of cosine squared x times sine x dx. As we did before, we can change the variable and let cos x equals t, like that. Differentiating both sides with respect to x and t, I'll be having minus sine x dx, which is equal to dt. Means that sine of x dx is equal to minus dt. And my integral becomes minus cosine x minus integral cosine x is t. T squared sine x dx is minus dt. So times minus dt. So this negative sign, that one, it will become positive. So I have minus cosine of x plus integral of t squared dt, and this is equal to minus cosine x plus 1 divided by 3, t power 3, then plus c, and I plus t by its value to get minus cosine x plus 1 divided by 3 cosine cubed x plus c. And I'm done. I hope that is very simple. Even if you change a 3, you put 5, it will work. If you put 5 here, 7, 9, still the message work, right? Now, apart from that method of reducing the power by 1 and introducing this trigonometric identity, we can use the reduction formula. And remember, I told you that the reduction formula can work for the power function for sine and cosine when n is either even or odd as well, right? So reduction formula. Use of reduction formula. So when you have integral of this form, cosine n x dx, then in is equal to 1 divided by n, cosine of n minus 1 x times sine of x plus n minus 1 divided by n, I power n minus 2. Of course, n is greater than or equal to 2. Also, if you have in, which is the integral of sine of n x dx, you'll be having in, which is equal to, this is positive here, it will be minus 1 over n, sine of n minus 1 x times the cosine of x plus n minus 1 divided by n, in minus 2. Of course, n is greater than or equal to 2. And this is known as reduction formula for sine and cosine power n, right? We are going to use this formula for evaluating the integral, let's take integral sine 5x dx. Here you have the exponent is 5. Means that we have I, 5, n is equal to 5, which is equal to integral of sine 5x dx. Applying the formula, it will be minus 1 divided by 5 is n is 5 times the sine of 5 minus 1 x times the cosine of x. Are we together? Okay. Plus n minus 1. That is 5 minus 1 divided by 5. I 5 minus 2. So this is equal to neg 1 divided by 5 sine 4x times the cosine of x plus 4 divided by 5 I3. Means that I3 n is equal to 3. We're going to find I3. You have to be careful when you use that formula, because one mistake, you can't get the answer. So we have to be careful on that. So I3 is equal to integral sine cubed x dx, as we deal with a function with sine, right? So I3 is this one. Still using our formula, it will be minus 1 divided by 3, sine cubed minus 1 x times cosine x, plus n, 3 minus 1 divided by 3, I3 minus 2. Are we together? So this is minus 1 divided by 3, sine squared x times cosine x, plus 2 divided by 3, I3 minus 2 is 1. Means that I1 is equal to integral of sine power 1 x dx. And this is very simple. This is equal to minus cosine x. Then I go back my integral. It was 1 I5, which is equal to minus 1 divided by 5, sine 4x times cosine x, plus, I start by here, 4 divided by 5I3, plus 4 divided by 5I3 is minus 1 divided by 3, sine squared x times cosine x, plus 2 divided by 3, I1. I1 is minus cosine x. So here we have negative 1 divided by 5, sine 4x times cosine x. This will be minus 4 divided by 15. 4 divided by 5 times negative 1 divided by 3. Then sine squared x cosine x. 4 divided by 5 times 2 divided by 3, it will be 8 divided by 15. It will be negative, as we have a negative sign here, minus cosine x plus c. It means that integral of sine 5 x dx is equal to minus 1 divided by 5 sine 4x times cosine x minus 4 divided by 15 sine squared x times cosine x, then minus 8 divided by 15 cosine x, then plus c. That should be the answer. And you can do the same if you change, instead of sine 5x, you take cosine 5x, dx, and so on. Let me give you this time, short time, to write that answer. Thereafter, I leave you a homework. Hurry up, please. You are waiting for the homework. All right, here you are. Evaluate the following integrals. Of course, you apply all methods you know. It is not a must to see, oh, it is even, when it is even or odd. I'm going to use the linearization. I'm going to use the trigonometric identity. You can use different methods you know. Number one, you have integral cosine 7x dx. Then integral cosine 9x times cosine x dx. 3 sine 5x dx, then sine 7x dx, and the last is integral of sine 9x dx. Thank you for your participation, your hard working, because I know this unit is not very easy. But if you decide to work, I'm very sure you will make it. Hope to meet you next time. Enjoy mathematics.